As part of science, we do a lot of lab activities. And when we do those lab activities, we collect data, numbers, quantitative or qualitative data that we can use in order to support or not support our hypothesis. When we have all of that qualitative or quantitative data, we need to be able to organize it in some way. And the best way to do that is a graph. So let's talk about how we can use graphs in science. Okay, there's your essential question. How do scientists use graphs? What scientists do with graphs is we are able to see trends. They help us make predictions. We can recognize maybe some inconsistent data or outliers, things that just don't make sense. So graphs are really useful to us and great visual aids. They display categorical and numerical data. So what's the difference between those two? When we're talking about categorical data, we're talking about categories, ways that we can group things. How many people maybe at a school have the same name? How many people are the same age? How many people have the same favorite color? Versus numerical data. That comes from measurement. Whether we're taking the temperature of something, we're getting the mass, the size. So we can see kind of the difference here pretty clearly. Categorical, based on categories, numerical, based on numbers. So let's talk about the different kinds of graphs that we can use. Line graphs are great for that numerical data, for those numbers. They can show us how, when we're doing an experiment, the dependent variable changes in response to the independent variable. And on a line graph, the independent variable always goes along the x-axis, while the dependent variable goes up and down on the y-axis. Bar graphs are great for both categorical and numerical data, and again, allow us to see either categories or trends that are taking place with the data we collect. Now, graphs where we end up with a straight line are called linear. If a graph has data points that don't fall in a straight line, then we call that nonlinear. When one point is clearly not part of the trend, so most of the points are following in that linear, falling on the line. They are linear, but we've got one that just doesn't really make any sense. That is called an outlier. And so we've got to take a better look at why that one happened. So there we have some linear and nonlinear graphs. Here we can see clearly a straight line. Here, it's not a straight line, but the data does follow a trend. Here, we've got mostly a straight line, but we've got an outlier all the way up here. So we've got to take a look at why that outlier happened. Okay, so now you know some more about graphs and how they're used and what they're used for, the different types. So now let's practice.